Okay, so the second part of our lecture is on types of motion. So you just finished a little activity where you were rolling things across the table, dropping things, sliding them down an incline, throwing a ball. So hopefully you got to see a little bit about the motion. Hopefully you were able to group them. So things being tossed, grouping them together, things rolling, obviously grouping them together, different speeds. So what we're going to look at with different types of motion is how we actually go about describing it. So the first way that we describe motion is by distance or displacement. Okay, your distance is looking at how far you travel regardless of the direction. So think of your distance as literally how many steps do you take in a day. So if you have a Fitbit, you have an Apple Watch, whatever it is that tracks how many steps you have in a day, that's looking at your distance. It doesn't care whether you're going north or south. It just keeps adding the steps up and up and up. Another example of distance would be your odometer in your car. So as you drive your car, it doesn't matter whether you're going backwards or forwards. It's just going to sit there and keep adding miles up and up and up and up and up. Okay, your distance is always going to be measured in meters. Okay, so we represent distance by an S, and then the unit is an M, okay, for meters. So S is going to be your distance, and then the unit is going to be in meters, okay, that SI unit. Your displacement is looking at your change in your position. Your displacement can either be delta X or delta Y. So you'll either write it down as an X or Y, just depends upon which way you're going. This one is also going to have units of meters as well, since it's still a length. So if you have an X displacement, that means that you're moving either horizontally left or right. A Y displacement means that you're moving up or down. That delta that's in front of there always means change. So when we're talking about displacement, we're talking about delta X or delta Y, so you're changing your position. You're going to see delta a lot. Delta V, delta F, delta T. Okay, so anytime you see change, change always means final minus initial. So if you're saying delta X, it means final X minus initial X. If you're saying delta Y, final Y minus Y initial. Okay, the key thing about displacement is that you have to worry about the direction. So left is negative, west is negative, south is negative, down would be negative, and we keep all of that in accordance with your normal XY graph, so your normal coordinate plane that you're used to. Okay, so here's an example of finding your distance and your displacement. So you have a person that moves in a straight line from the lockers at a position of 1 meter, and they're moving towards a physics lab at a position of 9 meters, as shown below. So you're starting over here at the 1 meter mark. Okay, over here, this is your starting position. You walk all the way down, you end over here at this position. So to find your displacement, you would do final minus initial. So your final would be x2, which would be 9. Your initial is x1, which would be 1. They're both to the right of your axis. If you look over here at your frame of reference, your axis over here, they're both on the right hand side, so they're both positive, so it becomes 9 minus 1, which would be 8. You can either put plus 8, 8 to the right, 8 east, any of those things. You do not have to put positive and east. That's redundant. Okay, so just one of the two. In this example, your distance would be the same as your displacement, because you simply just moved 8 meters, going from 1 meter to 9 meters. Okay, now if the person turns around, so now they went from 9 meters back to the 1 meter. So your displacement would be, you started for the, if you do it for the first part, you would be looking at the fact that you started at 9 meters over here, you ended at 1 meter. Okay, you're still on the right hand side of the axis, so it would be 1 minus 9. 1 minus 9 would give you negative 8, so that's telling you that you're moving to the left. Your distance is always going to be positive. okay, since we don't take into account that directionality. So your distance for that trip, so if you wanted to put that on there, S would be 8 meters, okay? If you're looking for your displacement for the entire trip, you started at 1 meter, you ended at 1 meter. So final minus initial, 1 minus 1 would give you 0, so your displacement is 0. Okay, your distance, however, you would add up the two of them together. So it would be distance 1 plus distance 2, 8 plus 8, which would give you 16. Okay, so your distance and your displacements are not always going to be the same. They can be. Another way to think about this is think about, where do you start your day? You start your day at home in your bed, okay, when your alarm goes off. You get ready, you go to school, you spend your whole day at school, you go through all your classes, maybe you go to work after school, you go to practice, whatever it is, and you eventually, at the end of the day, you go home and you end your day back in bed. So your displacement for a school day is 0, because you started in your bed and you ended in your bed. Your displacement is the same as if you would have just spent the whole day in bed. It would still be 0 because you didn't go anywhere. Okay, now your distance is going to be completely different from the 2, because as you walk to school, you're adding in all those steps, but your displacement would be 0. Okay, let's work at a homework problem from your packet. So the first one we're going to do is actually going to be homework problem number 2. Sorry about that stray mark. So problem number 2 asks for your distance and your displacement in the problem. So you're going from A to B, B to C, C to D, and you need to find your distance and displacement. We're going to start with distance. It doesn't matter. So we're looking for S. So that's going to be our unknown. Then, to find your distance, we're first going to look at the distance from A to B. So A to B moves from this straight line from A all the way to B, which ends up being 180 meters. 40 plus 100 plus another 40. Then you look at the distance B to C. So now you're going from over here at B, going to C, which is right here. So B to C would be another 140 meters. And then you're looking at C to D. So C to D would be this last distance here, which would be 100. And if I want to find my distance, all I do is I add them up. So 180 plus 140 plus 100 is going to give me 420 meters. So this is my distance. Okay, if you'll notice, that's what I'm talking about when I'm saying show your work. It's not as difficult right now. It's not as big of an issue, but you need to show me something. So delta S up here, looking for by unknown. Okay, what are you solving for? Then the next thing it asks is for my displacement. So I'm going to label my displacement as delta X since I'm moving in the horizontal. And since I'm looking for my displacement, I'm looking at how far A and D are apart from one another. So in a straight line, your displacement is always going to be a straight line start to finish. So if I look at A over here, I look at D, look at how far apart they are. They're 140 meters apart. So my delta X would be XF minus XI. I ended at 140 meters. I started at 0, which would be 140 meters. And again, to the right, to the east, since it's positive. So I'm just going to put to the right. Okay, so that's it. Okay, for that problem. Finding your distance and your displacement. Okay. Now we're going to add in the time factor. So we look at your average speed and your average velocity. Your average speed is looking at how fast you're going. So anytime you see this word speed, you're looking for fast. Okay, so how fast is something traveling? In today's society, we use speed and velocity interchangeably. They are not the same thing. Your speed is looking at the rate at which your distance changes. Since distance is not based on direction, that means speed is not based on direction. Okay, so your speed is always going to be a positive value. Since distance is positive, time is positive, that means that your speed is always going to be positive. Sorry for the bad handwriting. Okay, so then your equation for speed, which you do need to memorize, is going to be distance over time. Distance, if you remember, is measured in meters. And then time is measured in seconds. So your unit for speed is going to be meters per second. Okay, every time. Your velocity, on the other hand, is looking at the rate at which your displacement changes. Just for a frame of reference, anytime you see the word rate, that always means something divided by time. So if we said the rate at which work is done, the rate at which your velocity changes, we're telling you that in the denominator of your equation, you're going to have time. Okay, since your displacement, again, depends upon direction, that means that your velocity is also based on the direction. Okay, so make sure that you're worried about that direction the entire time. So positive and negative. So your velocity is going to be delta x over delta t. Again, delta x is measured in meters. Time is measured in seconds, so your unit for your velocity is going to be meters per second. This line that's over your speed and over your velocity, that just means that you're finding an average. It's a little shortcut that we use in physics. Instead of trying to write like AVG or something like that next to things to try and label it, you can just put the line over it. That means average. Okay, so let's do an example. So let's look back at your homework packet and let's look at number 5. So number 5 basically wants you to go back to using problem number 2, and it wants you to find the average speed and the average velocity of the cross-country skier in meters per minute. So notice they're telling you minutes, so you don't have to do the conversion, which is really nice. So when you label out your givens, you had your distance from earlier. Sorry, not delta. Your distance was S, okay, and your distance was 420 meters. Your displacement was 140 meters to the right. By the way, if S confuses you for distance, you can also use D for distance. It doesn't matter to me if you use S or D, okay, for it when you're looking at it. Some of the homework solutions use S, some of them use D, so just be careful when you're looking at them. Delta X is 140 meters to the right, and then you know your time is 3 minutes, and you're looking for V, and you're looking for S. So velocity is displacement over time, so 140 over 3. So my velocity is going to be 46.67 meters per minute to the right. Make sure you include that directionality. Then when you go to find your speed is going to be your distance over your time. I'll use D so that way it doesn't confuse you. So your speed is going to be 420 over 3. Which is going to give you 140 meters per minute, and no direction is necessary. Okay, So that's how you do those problems. Okay, make sure you memorize your equations. Okay. Next one you have is number 9. We're going to go through that one next. Number 9 is a little longer, a little more complicated. So it says a bus travels 280 kilometers south along a straight path with an average velocity of 24 meters per second to the south. The bus stops for 24 minutes, then it travels 210 kilometers south with an average velocity of 20.8 meters per second to the south. How long does the total trip last in hours? And then what is the average velocity for the total trip in kilometers per hour? Pay attention to your units. Okay, so we're going to start off by drawing a picture. That's where I'm going to label my given. So I'm going south first, and I know this distance here. Okay, so I know my displacement is going to be 280 kilometers. Okay, and I'm drawing the down arrow so that way I'm telling me my south. Then I stop for 24 minutes. I also know during the first part, sorry, I forgot about that, your velocity is 24 meters per second. And then I continue again. Now my displacement is 210 kilometers, again south, but I'm doing the down arrow. And my velocity is 20.8 meters per second. Both of those are south. So I'm just going to add a little south S next to those so that way I know. Okay. So the first thing I'm looking for is T total. Okay, I'm going to put T tot for T total, just so that way like I'm abbreviating it. So the first thing that you need to do is you need to figure out the total time during each section. So I need to figure out how long was I in this first section and how long I was in this third section. So your T total is going to be T1 plus that stoppage time plus that third time. So T1 plus T2 plus T3. Okay. So to find T1, okay, I'm going to go back and I'm going to have to use my velocity equation. So I know velocity is displacement over time, but I'm going to solve it for time. So I'm going to multiply both sides by T. So I get TV equals delta X. So then I can divide by V and get T is equal to delta X over V. This is again what I'm talking about, showing your work. Show me all of these little steps. If you look at your distance, though, look at your units. Okay, you're not in the same units. Your displacement's in kilometers. My velocity is in meters, so I need to convert this kilometers. So going back to that first PowerPoint, kilo means 1,000. So my displacement is really 280,000 over my velocity, which is 24. So 280,000 divided by 24. Okay, and then this is in seconds. So we'll go ahead and convert that to minutes. 60 seconds is 1 minute. So my time, so T1 is 194.44 minutes. Okay, go ahead and round everything always to the hundredths place. I know in chemistry they worry a lot about significant figures. In physics, it's not tested on the AP test. Y'all are in pre-AP, so we're prepping you for AP, so don't even worry about don't worry about significant digits. Just keep everything to the hundredths place. Okay, now you're going to do the same thing for T3. So again, I have my velocity equals delta x over t. So TV equals delta x. So delta x over v. So then t is going to be my new displacement. Again, it was 210 kilometers. So that's going to mean it's 210,000 over my velocity, which was 20.8. So my time $10,096.15. That's still in seconds, so again I'm going to convert it. 60 seconds in 1 minute. So 168.27. So now to find my total time, I would add those values up. So 194.44 plus the stoppage time, which was 24, plus 168.27. Gives me 386.71 minutes, but if you look at the problem, they want it in hours. So that means I'm going to have to convert that. So 60 minutes in 1 hour will give me 6.45 hours. That is your answer for part A. I know it's a lot of work, so I'm going through this one with you, okay, so that way you can see it. Okay, then for part B, part B then wants to know what is your average velocity, okay? Your average velocity, you cannot just add your two velocities and together and divide by 2. It's not how it works. If you think about your average velocity, by definition, it is delta x over delta t. So you look at how far did you move all together. It's all in the same direction. Also check the unit, so your answer that it wants for this one is in kilometers. So my displacement for this one would be 280 plus 210. So delta x is 490 meters south. And then my time would be that value that I just saw for in part A. So velocity 490 over my time 6.45. Which gives me an answer of 75.97 kilometers per hour south. Make sure you put that direction on there since it wants for your velocity. Okay, next class you are going to have a homework quiz. Okay, over a 1.1 and 1.2. Could be any of the problems from 1.1 and 1.2 except for the challenge problems. So if you look on your packet, number 13, for example, says that it's a challenge problem. Challenge problems will never be on homework quizzes. They're harder problems, something to give yourself, if you think this stuff is easy, it gives you a good way to practice to see if you can do the hardest problems. But it will not appear on a homework quiz. Not all homework quizzes are going to be announced, so we're kind of giving you a little easy one to start off with by telling you. So if you just stay up with the homework, you'll be fine on all the homework quizzes, pop quizzes, whatever they are. But again, the challenge problems will never be on a homework quiz. Okay, so if you don't get the number 13, it's okay. Relax, you'll be all right. The homework solutions will be posted online on It's Learning, and then your sub will also have access to the binder that has the homework solutions in there if you want to check those out as well. So that way, if you have any questions while you're working on it, you can do that. You can also look back at some of my other videos to help you out with that. Ay, ay, ay.